All right, so a little bit more with measurements here again, but hopefully by now you're seeing the pattern where as long as you know the conversion from one unit to the next, we can just use that dimensional analysis to get the answer. Or if you're working within the metric system, then you can just count and multiply by tens or divide by tens, which is pretty easy. But for most of this, if you have the conversion factor, then you can just go ahead and use that dimensional analysis. So it's a skill that you can really take to lots of different fields. Particularly, I feel like in nursing and anything with medicine, there's so much conversion going on between a patient's weight and the medication administered. So that's just one example here. Another silly example, I know as a child, I had a pen pal who lived in Sweden, and everything for her was within the metric system. So again, just kind of a weird example, but I had a hard time figuring out things that she would tell me because I couldn't relate it to the English system. So you never kind of know when you may need a conversion from one to another. I know for me too, when I bake a lot, sometimes I need a conversion for teaspoons to tablespoons or something like that. So it is a helpful skill to have to be able to convert between different units. So the last thing we're going to talk about here would be weight and temperature. So weight is actually a measure of the gravitational pull on an object. And the gravitational pull on the moon actually is different than the gravitational pull on Earth. So, hang on one second. Okay, sorry about that. So the gravitational pull on the moon is only about 1/6 the gravitational pull on Earth. So although your weight varies depending on the force of gravity, your mass actually is the same. So your weight can vary depending on gravity, but the mass is the same. So the mass is the measure of the quantity of matter in an object. It's determined by its molecular structure. So there's kind of two different things here. However, on Earth, as your weight increases, so does your mass, excuse me. So in this section, we're going to assume that measurements involved deal with everything on the surface of Earth. So we're not going to really distinguish here too much between weight and mass. We're going to kind of stay on Earth and treat it as the same thing to make it a little bit simpler. So we're going to treat weight and mass as equivalent and refer strictly to weight in our discussion for the rest of the unit. Now, here's your conversions for weight. So for the English system, 16 ounces is the same as 1 pound. We use lb for pound. And 2,000 pounds is the same thing as 1 ton. And that's with a capital T here. For metrics, the basic unit is grams there. So G for grams. It's used for very small objects such as coins, candy bars, teaspoons of salt. For instance, a nickel weighs about 5 grams. As with meters, prefixes are used to denote multiple or parts of a gram. So you have that same distinction with the metric system, which is really nice. Kilo is 1,000, hecto is 100, deca is 10, and so on. So you have those, again, same prefixes. It's just that instead of being meters here or liters, we're in grams. But it's really the same conversion process. In the metric system, a kilogram is what is comparable to pounds in the English system. So the weight of 1 kilogram is about 2.2 pounds. And I know this is something that actually gets used a lot, particularly in the medical field. A lot of dosages are given in kilograms, not in pounds for the patient. So there is a lot of conversion that has to go on there. So the average man has a weight of about 75 kilograms. And objects that we measure in pounds are measured in kilograms in most countries. Okay. A milligram, which is the same thing as 0.001 gram, is an extremely small unit of weight and is used extensively in the pharmaceutical industry. So again, if you look at the labels on bottles of tablets, you will see that the amounts of different substances in each tablet are typically expressed in milligrams. If it's a liquid dose, like we saw in the last piece, it would maybe be in milliliters. But again, if it's a tablet or something, it would be in milligrams. Now, this is actually really important to note here. The weight of very heavy objects is expressed in terms of a metric ton in the metric system, which is equivalent to 1,000 kilograms or about 2,200 pounds. This is not the same as an English ton, which is 2,000 pounds. So watch your units here. A lowercase t is for a metric ton, which is 2,200 pounds in the English conversion. whereas an English ton, which is capital T, is 2,000 pounds. So you just want to be careful here of, again, the units and being really clear what your base value is. So is it a ton or a metric ton? Those are going to be different things here. Now, if you're converting within the metric system, it's the same conversion process. It doesn't matter what your base unit is. So if it's meters or liters or grams, it's still that same division or multiplication process, which is really nice. It makes the metric system easy to use. So again, we're staying within the metric system here. So I'm going to go from 8.7 decigrams to milligrams. So let's see, I'm going from DG, next is CG, and then MG. So I'm going from here down to here. So I'm moving in that right direction. So remember, if you're going to the right, you're going to multiply by 10. So I'm going to do it twice. So I'm going to multiply by 10 once and by 10 twice, which means I'm actually just going to move that decimal 2 spots to the right. So this is the same as 870 milligrams. Now for B, we're going to go from 950 milligrams to grams. So let's see, I have milligrams, I'm going up to grams. So I have G, DG, CG, MG, just for my notation here. And I'm going from milligrams to grams. So I'm going up or to the left. And if you're going to the left, remember you're going to be dividing by 10 in that case. So I have to do it once, twice, 3 times. So that 950, my decimal points on the right is going to go left 1, 2, 3 times. So 0.950 or 0.95 grams here. Now, the nice thing with this system, again, is just look at the direction you're moving. If you're moving to the right, moving the decimal to the right. If you're moving to the left, you're moving the decimal to the left. So it's just a nice, easy conversion that you can do if you're within the metric system. Okay. So we saw before that there is a convenient relationship between the metric system, in the metric system between volume and capacity. And we've seen this one before. So 1,000 cubic centimeters is the same thing as 1 cubic decimeter is the same thing as 1 liter. And we can also extend the similar idea to weight. So 1 liter is going to be the same as 1 kilogram. And it's going to give us the following conversions. So this is kind of, a lot of it we've already seen. You know, for instance, we've seen this already, but we're just kind of changing over and also bringing in weight here. So 1 liter and 1 kilogram are going to be the same conversion. So you can use this table now too. All right, so let's do some examples. And it says an aquarium holds 0.25 cubic meters of water. How much does the water weigh? So we're looking for weight here, which means that we're looking for some sort of grams, typically kilograms here, in the metric system. So we want to go from 0.25 cubic meters. I'm going to go over here to my conversion. And I do see that for cubic meters, I can convert to kilograms. So that's what I'm going to do. So 1 cubic meter is 1,000 kilograms. Okay. So the cubic meters are going to cancel. Dividing by 1 isn't going to change anything. So I have 0.25 times 1,000 kilograms. And I'm looking at 250 kilograms here. Now there are other equivalents as well, of course. So from English to metric, we do have that 1 ounce is about 28 grams. Again, these are approximate. 1 pound is about 0.45 kilograms, and 1 ton is about 0.9 tons in the metric unit. So let's convert from 160 pounds 2 kilograms. So I have 160 pounds. Again, I want to get rid of pounds and I want to go to kilograms. So I see that 1 pound is about 0.45 kilograms. So 0.45 kilograms for 1 pound. My units will cancel. Dividing by 1 isn't going to change anything here. So I have 160 times 0.45. And let's see, if I multiply that out, I'm going to get 72 kilograms. For the second one, we're going from 300 grams to ounces. Okay, so I want to get rid of grams. I want to go to ounces. I'm going to look and see if I have a conversion, which I do. So 1 ounce is about 28 grams. And I guess, these are approximate because we're rounding here for equivalence. So timesing by one isn't going to change anything. So I have 300. My grams will cancel. So I have ounces divided by 28. And when I divide that, I get about 10.7 ounces. So 300 grams is about 10.7 ounces. All right. One last example here with weights, and again, this is a really common application here. So drug dosage is frequently based on a patient's weight, and it's often given in kilograms. So for example, 20 milligrams of the drug Didronol, which is used to treat irregular bone formation, should be administered daily for each kilogram of a patient's weight. So we're giving 20 milligrams for each kilogram. When you see that word each, you want to think 1. So we give 20 milligrams per 1 kilogram of weight. So this can be expressed as 20 milligrams per kilogram. How many 400 milligram tablets should be given each day to a patient who weighs 80 pounds? So when you have pounds here and you're dealing with medication, typically the first thing we need to do is we need to take those pounds and we need to convert it to kilograms because most of our medication dosage are given in kilograms, are based on a person's weight in kilograms. So I want to go to kilograms here and I want to get rid of the pounds. So 1 pound is about 0.45 kilograms. Again, dividing by 1 isn't going to really change anything. So I have 80 times 0.45. And I get 81 kilograms. So the first thing is I have to figure out how much this person weighs in kilograms. So they weigh 81 kilograms. Now for this example, I know that I have to administer 20. So I'm going to give 20 milligrams of the drug for each 1 kilogram of body weight. So the next thing I need to figure out is, well, how much does the person actually need of this drug? So now I'm finding the dosage. So I have that they weigh 81 kilograms, and I want to figure out the milligrams. So I'm going to go to milligrams of the drug for a kilogram of body weight. So it's 20 milligrams for 1 kilogram of body weight. So I'm looking at 81 times 20 here. Again, divided by 1 is not going to make a difference. So I'm looking at 1,620 milligrams of the drug is what they should be taking each day. Now, the problem is I have 400 milligram tablets. So how many of these am I going to give? So the number of tablets I'm going to give here is I have my 1,620 milligrams. I want to go to tablets, and each tablet has 400 milligrams of the drug. So I'm basically looking at 1,620 over 400, which is equal to 4.05 tablets. So finally, we're done. So at this point, 0.05 is very, very small, right? So we would give that person 4 tablets of the drug for the entire day. So when we're doing medication, first thing I had to do was change from pounds to kilograms. This is very common. Second thing I had to do was actually figure out the dosage. So now that I know the kilograms, I know how much of the medication they should be getting. And then in this case, I had a third step because my tablets came only in 400 milligram tablets. So I need to figure out how many tablets should that person take. They should take 4 tablets per day. Now, the last thing I want to talk about here, and I figure we'll do it the same video because it's actually pretty quick, is temperature changes. So there are 3 scales that we typically use for temperature. The Fahrenheit scale, which is often used in the United States, the Celsius scale, which is often used in countries that use the metric system, and then there's also the Kelvin scale, which is typically used in science. So just a couple little facts here. So in the Fahrenheit scale, water freezes at 32 degrees and it boils at 212 degrees. In the Celsius scale, water freezes at 0 degrees and boils at 100 degrees. Note, sometimes the word degrees and centigrade are used interchangeably. So you may see that too. Centigrade was used before, but now degrees is more popular. Now, the Kelvin scale is actually the same as the Celsius scale, except for the starting point is 0 instead. So water freezes at 273.15 degrees, 15 Kelvin, excuse me, not degrees Kelvin, and it boils at 373.15 Kelvin. And again, this scale is typically used within the scientific community. So with the Kelvin scale, it's different because it starts at 0, so it doesn't use negative values. Whereas for the Fahrenheit and Celsius scale, we do use negative values here. We can convert from Celsius to Fahrenheit by using this formula. So you just plug in the Celsius value and it will spit out the Fahrenheit. We can go from Fahrenheit to Celsius using this formula. And there's no examples here, but converting from Celsius to Kelvin is pretty quick back and forth. So in one case, you're adding 273.15. In the other case, you're subtracting. And then if you need to go from Kelvin to Fahrenheit, you would just go to Celsius first, and then from Celsius to Fahrenheit. So you would do that intermediary step. All right, so the bills from your European vacation have you feeling a bit feverish, so you decide to take your temperature. The thermometer reads 37 degrees Celsius. Should you panic? Well, being that most of us in class are probably from the United States or used to using Fahrenheit for degrees, let's change this to Fahrenheit so that we have a better understanding here. So to go from Celsius to Fahrenheit, we're going to use the formula. Now, F is for Fahrenheit here and C is for Celsius. So my C is 37 degrees, so I'm going to plug it right into the formula. So the biggest thing here that you're going to have an issue with is maybe your calculator. So when you go ahead and you multiply, you just want to keep in mind that this is one fraction, so you can either do it as 9 times 37, so do the numerator first, and then divide by 5. Or keep the 9/5 in parentheses, and then just multiply by 37. So either way is okay, but you need to make sure that you're multiplying the right numbers together here. And then when I add the 32, I get 98.6. So this answer is 98.6 degrees Fahrenheit. So should we panic? Our answer would be no, right? 98.6 degrees Fahrenheit is considered a normal temperature for most people on average. So that would be totally normal and you shouldn't worry. The temperature on a warm spring day is 77 degrees Fahrenheit. Let's find the equivalent on the Celsius scale. So if we're going from Fahrenheit to Celsius, we're going to use this formula. Basically, say that's pretty much the opposite, right? So our Fahrenheit here is 77. So we're going to plug that in. Now, you do want to follow the order of operations, so make sure you do inside the parentheses first here. So 77 minus 32 is going to be 45. And then again, you're going to multiply. So either multiply your numerators and then divide by the 9. Okay. So you can do 5 times 45 here, and then divide by the 9. and you get 25. Or you can do the 5 nines in parentheses and then multiply that by the 45. So you'll get 25 in either case. So the equivalent here is 25 degrees Celsius. So if you're traveling somewhere else that uses Celsius instead, and they say it's 25 degrees out, that sounds pretty nice. It's actually about 77 degrees in Fahrenheit. So it is good to be able to go back and forth, again, particularly if you're traveling, or even if you're watching maybe like an international news or reading international papers. Again, a lot of places use metric system and they also use Celsius instead. So it's good to be able to go back and forth between the two.